Hello students, I welcome you all to the platform of Infinity Vision. Hope you all are doing well. So today I am here with you to discuss the complete solution of JEE Mains Physics paper of January Shift 2024. As you can see on the screen behind me, the physics paper is of morning shift that was conducted by NTA on 29th January. The timing was from 9 a.m. to 12 p.m. So let's start. So this is section A, the MCQ type questions. There will be total 20 questions in this section. So starting from the first question. So this question is from Zener diode. In the given circuit, the breakdown voltage of the Zener diode is 3 volt. What is the value of IZ? So we have to find the current through the Zener diode, and the breakdown voltage of the Zener diode is given as 3 volt. So it's a very simple question. If we can see over here, the breakdown voltage is given as 3 volt. The breakdown voltage of the Zener diode is given as 3 volt. Now, since this 2 kilo ohm resistance is connected in parallel, so the voltage across this 2 kilo ohm resistance will also be 3 volt. The voltage across this 2 kilo ohm resistance will also be 3 volt because it is connected in parallel. So now, if we take this as the current here I1, and here it is IZ, and here total current I. So here, since the potential is 3 volt across this 2 kilo ohm resistance, so the remaining potential, and the battery is of 10 volt, so here will be 7 volt. And the potential drop across 1 kilo ohm resistance will be of 7 volt. 7 plus 3 will be equal to 10. So now if we calculate the current I1, the current I1 will be V by R, and V is 3 and R is 2000 ohm. So it will be I1 will be 3 by 2000 ampere. And if we calculate capital I, this current, then it will be again V by R, and V is 7 and this is 1000 ampere, which can be written as 14 by 2000 ampere. Now, I is the total current, and it is being divided into two parts, IZ and I1. So clearly IZ will be I minus I1, and I is 14 minus 3 divided by 2000, and it will be 11 by 2000 ampere. So converting into milliampere, we will get 11 by 2 equal to 5.5 milliampere. So the correct option for this particular question will be option number 2, 5.5 milliampere. The current through the Zener diode will be 5.5 milliampere. It's a simple circuit of Zener diode. Now coming to question number 2. The electric current through a wire varies with time as I equal to I naught plus beta t, where I naught equal to 20 ampere and beta is 3 ampere per second. The amount of electric charge crossed through a section of the wire in 20 seconds is. This question is very basic question from electric circuit. The variation of current is given as I barabar I naught plus beta t. And the value of I naught and beta are already given. So the current can be written as dq by dt. And this will be equal to I naught plus beta t. dq will be I naught dt plus beta t dt. Integrating both sides, we can have, if we integrate both sides, then we will get dq equal to I naught dt plus beta t dt. 20 seconds का टाइम ये बोल रहा है कि 20 seconds में कितना चार्ज फ्लो करेगा. So let the amount of charge varies from 0 to capital Q, and time is from 0 to 20 second. Here also time is from 0 to 20 second. So if we integrate this, we will get I naught t plus beta t square by 2, and the limit will be from 0 to 20 second. So now substituting the values of all the quantity that is given in the question. Here dq will be converted into q, and here I naught is 20 t plus beta is 3 by 2 t square, 0 to 20, 20 into 20 plus 1.5 into 400. So here this will be 400, and this will be 600, and it will be 1 1000 coulomb. So the charge pass will be 1000 coulomb. So the correct option for this question is 1000 coulomb. So it's a very basic question of electrical circuit. ठीक है ना, बस करंट के एक्सप्रेशन को डिफरेंशिएट कर देना था चार्ज के टर्म्स में और फिर इंटीग्रेट करके आंसर ले आना था. तो 400 plus 600 is equal to 1000 coulomb. Now coming to question number 3. This is statement-based question. It's a very simple question based on surface tension. Statement-based question. We have to check which statement is true and which statement is false, or if whether both are true or false. Let's see. So statement 1 is, if a capillary tube is immersed first in cold water and then in hot water, the height of the capillary rise will be smaller in hot water. Now we know that the expression for capillary rise is 2s cos theta upon rho gr. Here S is the surface tension of the liquid in which the capillary tube has been immersed, theta is the contact angle, rho is the density of the liquid, g is the acceleration due to gravity, and r is the radius of the tube. Keeping all things constant, we can see that H is directly proportional to S. Capillary rise of a capillary tube is directly proportional to surface tension. Now surface tension is inversely proportional to absolute temperature. Higher the temperature of the liquid, lower will be the surface tension. ठीक है ना? तो अगर पहले हम कोल्ड वाटर में हॉट इमर्स कर रहे हैं, so cold surface tension is inversely proportional to temperature. If temperature is low, then surface tension is high, so H will be high. So clearly capillary rise for cold water is greater than capillary rise for hot water. This is true. Capillary rise hot water में कम होगा, so smaller in hot water लिख रखा है इन्होंने, so this is true. Statement 1 is perfectly true. Statement 2, if capillary tube is immersed first in cold water and then in hot water, the height of capillary rise will be smaller in cold water. This is absolutely false because it is contradicting the first statement. So statement 1 is true, but statement 2 is false. So correct option will be option number 3. As we can see, statement 1 is true, but statement 2 is false. This is based on the simple property of surface tension, which is inversely proportional to the temperature of the liquid. Now coming to question number 4. Next question. A convex mirror of radius of curvature 30 centimeter forms an image that is half the size of the object. The object distance is. Very simple question from the geometrical optics. A convex mirror there is given in the question. This is convex mirror. This is a convex mirror and this is the principal axis. So we already know that in case of convex mirror, this is pole, this is focus, and this is center of curvature. So radius of curvature is given as plus 30 centimeter. So focal length will be r by 2 equal to plus 15 centimeter. The focal length of convex mirror is positive. Now, regarding image, the information is given that image size is half the size of the object. We know that in case of convex mirror, always a virtual image is formed and the image is erect and smaller than the object. The size of the image is smaller than the object. So the magnification of the convex mirror is plus half. We can write plus half because it is an erect image. So minus V by U is equal to 1 by 2. So V equal to minus U by 2. So this is the relation that we can establish between image distance and object distance. Now just applying the mirror equation, 1 by F equal to 1 by V plus 1 by U. 1 by F is 15. V is minus U by 2 to minus 2 by U plus 1 by U equal to minus 1 by U. So here we can get U equal to minus 15 centimeter. Very basic question, very basic question. So the object distance that they are asking in the question is minus 15 centimeter. So the correct option is option number 1. Now coming to question number 5, two charges 5q and minus 2q are situated at the point 3a, 0 and minus 5a, 0 respectively. The electric flux through a sphere of radius 4a having center at the origin is. Now they are asking about two kinds of electric flux through a sphere. Let's draw a schematic of the question. Let's suppose this is our x-axis and this is the origin. This is the origin. 2 points are given. One is 3a, 0. One is 3a, 0. It will be on the right side. And other is 5a, 0. Minus 5a, 0. So it will be, let's suppose, here. A charge plus 5q is kept over here. This is the charge plus 5q. And minus 2q charge is kept over here. Now, they are talking about the electric flux through a sphere of radius 4a. Now, radius of the sphere is 4a. The sphere radius is 4a. So this is 3a. Let's suppose this is 4a. and the 4a will come out approximately over here. So this is the sphere that they are talking about. This is the imaginary Gaussian surface, we can say. This is the sphere through which we have to calculate the electric flux. As we know that from Gauss law, that electric flux phi is nothing but q in upon epsilon naught, where q in is the charge enclosed by the Gaussian surface upon epsilon naught. So if this is the Gaussian surface, this sphere is the Gaussian surface, if this particular sphere is the Gaussian surface, then if we can, so as far as the radius is given 4a, we can see that only 5q charge is being enclosed inside this sphere. This minus 2q charge is outside the sphere. So the charge which is outside this sphere has to be excluded. So the only charge that we have to keep in this problem is 5q. So the resulting flux will be simply plus 5q by epsilon naught. So the correct answer is 5q by epsilon naught, option number 2. Very basic question on Gauss law. Coming to next question, question number 6. In this question, a body starts moving from rest with constant acceleration, covers displacement s1 in the first p minus 1 seconds and s2 in the first p seconds. The displacement s1 plus s2 will be made in time. This question is based on kinematics, linear one-dimension motion. So just a schematic we can draw. Let's suppose this is point A, this is point B, and this is point C. Now, in the question it is said that the particle has covered displacement s1 in time p minus 1 second and displacement s2 in time p seconds. The information is, whatever information is given in the question, I have converted this information into a schematic. So you can see that p, quite natural is that p will be greater than p minus 1. So in p seconds it is covering displacement s2 and p minus 1 it is covering s1. So let's suppose a barabar acceleration of the particle, which is constant. So we can write s1 equal to ut plus half at square. Since it is starting from rest, so u will be 0, half a, and time is p minus 1 whole square. Similarly, s2 will be half a p square. Now, if we add both these two equations, we will get s1 plus s2 equal to half a p square plus p minus 1 whole square, which will be half a p square, expanding the bracket, p square plus 1 minus 2p, which will be equal to half a 2p square plus minus 2p plus 1. Now, if this is the displacement, if we regarding whose time they are asking the question, so if we compare this with this expression half a, this expression is holding the dimension of square of time. This particular expression is holding the dimension of a square of time. So the required time will be t square equal to 2p square plus 2p square minus 2p plus 1. So time will be root over 2p square minus 2p plus 1. So the correct option is option number 2, as you can see from the given options. The one mistake that basically students do, that they don't keep the square root. Okay, now they just simply think that this is the required time. So this is a mistake which is committed, and that option is also given in the question. So we have to be very careful in such kind of silly mistakes. Now, question number 7, the potential energy function in joule of a particle in a region of space is given as u equal to 2x square plus 3y square plus 2z. Here x, y, and z are in meter. The magnitude of x component of force in Newton acting on the particle at point P1, 2, 3 is. This question is from work energy power. The potential energy function is given as 2x square plus 3y square plus 2z. If we know that x component of force is nothing but partial derivation of, this is dou u by dou x, partial derivative of x, keeping y and z constant, y and z should be constant. So if we differentiate this expression, fx is equals to minus del u by del x. So if we differentiate this expression, we will get minus 4x, because this term and this term will be 0 as y and z are kept constant. So fx equal to minus 4x. Now the point they have given is 1, 2, 3. X coordinate is 1. So force x component will be minus 4 into 1 minus 4 Newton. the force is acting on negative x-axis, but since they have asked only the magnitude of the force, so the correct option will be option number 3, 4 Newton. The correct option will be option number 4. Now coming to question number 8, the resistance R equal to V by I, where V is equal to 200 plus minus 5 volt and I is equals to 20 plus minus 0.2 ampere. The percentage error in the measurement of R. It's a very basic question on relative error. We know that the relationship is given as R equal to V by I. So the relative error in resistance will be delta V by V plus delta I by I. Just division rule, delta V by V, delta I by I. So now delta R by R will be equal to delta V. Delta V is 5 by 200 plus delta I is 0.2 by 20. So this will be 7 by 200. Now for percentage error, we have to multiply both sides by 100. For percentage error, we need to multiply both sides by 100. So this will be 3.5%. So the relative error in the measurement of resistance will be 3.5%. Very basic question from the errors and measurement part, that is the first chapter, units and measurement. Now coming to question number 9. A block of mass 100 kg slides over a distance of 10 meter on a horizontal surface. If the coefficient of friction between the surfaces is 0.4, then the work done against the friction. This is very important. Against the friction means we have to calculate the work of friction and then we have to take the negative sign, because against the friction they are asking. So it's let's depict it on a diagram. Suppose this is a surface, and let's suppose there is a block whose mass is 100 kg and it is sliding on this surface over a distance of 10 meter. Let's suppose the block reaches over here and this displacement is 10 meter. This particular distance is 10 meter and the coefficient of friction is 0.4 between the surface and the block. So we know that the friction force is nothing but mu times n, kinetic friction, and n will be equal to mg because the block is moving on a horizontal surface. So the friction force will act in this direction, kinetic friction will act in this direction, and this will be the normal force and this will be the weight force. So normal and weight will be balancing each other for every instant, at every instant, because the block is moving on a horizontal surface. So this is the simple friction force expression. Now the work done by friction force, work done against friction force will be equal to, now friction force is acting on the leftward and the block is moving rightward. So work of friction is negative. So if we against the friction, the work will be positive. So it will be simply plus Fk into S mu mgs. Now substituting all the values, we can get mu is given as 0.4, mass is 100 kg, g is 10 and S is also 10. So from here we can say that this will be equal to 4000. The answer will be 4000 joule. Simple question of work, power, energy, one dimension motion. Now coming to question number 10. This question is pure theoretical question based on the 4 equations of Maxwell's that is given in the chapter electromagnetic waves. It's very simple, just we have to look into the expression and match the correspondence. So the first law is, this is the modified Ampere circuital law that was modified by Maxwell. So including the concept of displacement current. So option A is Ampere Maxwell, this is 4 for A, this will be 4. Ampere Maxwell's equation. Second equation, E dot dl equal to d phi by dt. This is the Faraday's law, because first electric field is induced and after that EMF is induced. So induced electric field expression is this. This is Faraday's law, option number 3. Then C phi E dot d equal to q by epsilon. This is electrostatics from Gauss law of electrostatics. So option 1. And finally this will be option Gauss law of magnetism 2. So the correct 4312. 4312. So option C, option 3 is the correct option for this particular question. Now coming to question number 11. If the radius of curvature of the path of two particles of same mass is same, the mass of both the particles are same, are in the ratio 3:4. The ratio of radius of curvature is given, then in order to have constant centripetal force, their velocity will be in the ratio of. Now see, for the first particle, the centripetal force will be mv1 square by r1. If a particle is encountering any curve, and this is the instantaneous position of the particle, so this will be the velocity vector. So a local radius of curvature, this r1, the local radius of curvature, the centripetal force will be act in this direction, and it will be equal to mv1 is mv square by r. This will be the expression of the centripetal force. It will act toward the center of curvature. This is the center of curvature C. So for first particle, the expression will be mv1 square by r1, and for second particle, the corresponding expression will be mv2 square by r2. Now in the question, the condition is given that we have to keep constant centripetal force. The centripetal force has to remain constant, means for both the particle, the centripetal force should be same. So F1 should be equal to F2. So equating F1 equal to F2, we get V1 square by R1 equal to V2 square by R2. So simply, here we can see that V1 square by R1 equal to V2 square by R2. So R1 by R2 equal to V1 by V2 whole square. So V1 by V2 equal to under root of R1 by R2. And ratio of radius of curvature is given as 3 by 4. So under root of 3 by 4 will yield as root 3 by 2. So ratio of speed will be root 3 is to 2, which we can see that it is in the option number 1. So the correct answer for this particular question is root 3 is to 2. The ratio of their speeds will be root 3 is to 2. Now coming to question number 12. A galvanometer having coil resistance of 10 ohm, this is the galvanometer resistance 10 ohm Rg we can say, shows a full scale deflection for a current of 3 milliampere. For it to measure a current of 8 ampere, the value of shunt should be. So let's draw a small circuit. This is our galvanometer. This is its resistance Rg, and this is the shunt that we have to connect in parallel, because we are converting the galvanometer into an ammeter. So this will be the shunt resistance Rs, and here the total current is 8 ampere, and in the galvanometer it is 3 milliampere. So from the shunt, the current that will pass through is 7997 milliampere. Okay, so now they are telling that what is the value of shunt resistance. Now since galvanometer and shunt are connected in parallel, so both will be having same potential difference. The potential difference across the galvanometer and the shunt will be same. So Vg will be equal to V shunt. So V equal to IR, 3 into Rg will be equal to 7997 into Rs. So Rs will be simply 3 into Rg by 7,997. Now Rg value is given as 10, and this is 7997. Now approximately we can round it off to 8,000 itself. Just for the sake of convenience, because the answer is cannot to avoid the calculation. So the final answer you can just approximate it as 30 by 8,000, and from here we can see that the answer will be 3.75 into 10 raised to the power minus 3. So the correct option for this particular question is option number 3. Now the second question, this question is from de Broglie wavelength, modern physics, dual nature of matter and radiation. This particular question says that the de Broglie wavelength of an electron is the same as that of photon. If velocity of electron is 25% of the velocity of light, then the ratio of kinetic energy of electron and kinetic energy of photon will be. Now in the question they are asking the ratio of kinetic energy of electron upon kinetic energy of photon. So kinetic energy of electron we can write as half mass of electron into velocity of electron square. Now kinetic energy of photon we cannot write as in this form, because photon has no rest mass. So kinetic energy of photon will be written as hc by lambda photon. This will be the kinetic energy of photon. Now just simplifying this, half MeVe into V, and here will be Hc by lambda photon. Now this particular expression is nothing but momentum of electron. So we can write half P electron V electron, and here we can keep it as Hc by lambda E. Hc by lambda E. So this is the final expression that we are getting. Now just I am deleting this portion and keeping that this is the expression of kinetic energy itself. So this is kinetic energy of electron upon kinetic energy of photon. Now again, just a little bit simplification. Half PeV, momentum of photon, here is the momentum. Now the momentum of electron from the de Broglie wavelength, we can see that H by lambda E. This we can use. This expression can be used over here. So kinetic energy of electron upon kinetic energy of photon will be half into P can be replaced by H by HV by lambda E, and here will be here will be lambda P photon, and lambda photon will go in the numerator, and here will be Hc. Now now in the question it is given that the de Broglie wavelength of electron and photon are same. So this term will be cancelled out. Planck's constant term will be cancelled out. So the expression will be VE upon 2C. VE upon 2C. Now in the question it is said that the velocity of electron is 25% of velocity of light. Velocity of electron is 25% of velocity of light, means velocity of electron is 1 by 4 times velocity of light, C by 4. So if we write here C by 4 into 2C, then we will get 1 by 8. So the ratio of kinetic energy of electron and photon, provided the de Broglie wavelength of both of them are same, is 1:8. So the correct option will be 1:8. Now coming to question number 14. The deflection in moving coil galvanometer falls from 25 divisions to 5 divisions when a shunt of 24 ohm is applied. The resistance of galvanometer coil will be. See, this let's draw a galvanometer first without any shunt. This is a galvanometer without any shunt, and the second diagram is the same galvanometer now connected with the shunt. This is the shunt RS and this is RG. Now in the first case it is being said that the deflection drops from 25 divisions to 5 divisions. First what we have to do, that let one division X ampere. One division of the galvanometer is showing 1 X ampere current. So 25 divisions will show 25X. So here the current is 25X. Now the same current 25X is being divided in two parts. Here it is going 5X and here it is going 20X. From 25, no, because now we have connected the shunt, so maximum current will flow through the shunt. So galvanometer, the current through galvanometer is 5X and current through the shunt is 20X. Now in the question the shunt resistance is given as 24 ohm and we have to find the resistance of the galvanometer. So just apply the potential difference concept. The potential difference will be same. So V galvanometer will be equal to V shunt. So here we can write that 5X into Rg will be equal to 20X into Rs. 5X into Rg will be equal to 20 into the 5X Rg is given as 24 ohm. Sorry, Rg we have to calculate. Rg equal to 20X into Rs is given 24. So x gets cancelled out, 5 4s are 20. So Rg will be nothing but 96 ohm. This is the final answer. 24 into 4, 4 4 16, 4 2 8 9. So the correct option for this question is 96 ohms. Now coming to next question, question number 15. A biconvex lens of refractive index 1.5 has a focal length of 20 centimeter in air its focal length when immersed in liquid of refractive index 1.6 will be. Now, this question is based on basic lens maker formula. So we know that the lens maker formula is given by 1 by F equal to mu L upon mu M minus 1 into 1 by R1 minus 1 by R2. Now, in the first, we will use this equation 2 times. In the first case, the focal length is 20 centimeter. So 1 by 20, lens refractive index is 1.5 minus 1. It is in air, and this is 1 by R1 minus 1 by R2. This is equation 1. In the second case, now the same lens is immersed in a liquid having refractive index of 20, having 1.6. So let's suppose the second case focal length is f2. Now the lens medium is 1.5 and the liquid refractive index is 1.6 minus 1, and this 1 by R1 minus 1 by R2 will remain as it is. Now 1 by R1 we can substitute 1 by R1 from there. So 1 by F2 will be equal to minus 1 by 16 and 15 by 16 minus 1 by 16, and here will be 1 by R1 before R2 3 by 0.5 by 2 10 0.1 by 10. So F2 will be nothing but minus 160 centimeter. So the focal length is negative. It's quite obvious because we are immersing the lens in a medium whose refractive index is greater than the refractive index of the lens material. So whenever the refractive index is greater than the lens material, the nature of the lens changes. The lens, the biconvex lens, which is a converging lens, will have focal length positive, but when immersed in a liquid, it will have focal length negative. It will become diverging lens. So the correct option for this question is option number 2. Coming to question number 16. Now this question is a bonus question because in this question none of the options given by NTA on the day of exam in their official paper is matching with the given with the answer that we will get finally. So this is a bonus question. This question is a bonus question. The marks will be given to the students who have attempted this question. Now what they are saying that this is a thermodynamic process that is depicted on this PV diagram. The pressure is in dyne per centimeter, the unit has to be kept in mind, and volume is in meter cube. Now this is the process path. In the first case, the gas is A to B, the process is expanded from A to B and then from B to C. This is the isobaric process. So A to B is an expansion process and B to C is a compression process. So now what they are asking the total work done from A to B and then B to C. Now in case of A to B, the total work will be this complete shaded part, the area of the trapezium. And in B to C, the area will be only this area of the rectangle, which will be negative. So when we will add these two areas, what the area with which we will be left is just the area of this right angle triangle. Just the area of this right angle triangle we will be left with. So we have to calculate just the area of this right angle triangle for getting our answer. So the area of required work equal to half into this area base BC into height AC. Now BC is 7 minus 3, 4 and AC is 8,000, 4,000, means 4,000 dyne per centimeter square, 4,000 dyne percent. Now 1 dyne is equal to 10 to the power 5 Newton. 1 dyne is equals to 10 raised to the power 5 Newton. And centimeter square 10 raised to the power minus 4. So if we will calculate from here, then we will get 4, 2 2s are 4, 4 2s are 8, and 800 joule we will be getting. But as you can see, the options provided in this question, none of the options are matching in this particular question. So this is a bonus question. So the correct answer will be 800 joule. Now coming to question number 17. At what distance above and below the surface of the earth a body will have same weight? Take radius of earth r. Very simple question on acceleration due to gravity. Let's suppose this is earth and here I take a point 1 and just below the surface of the earth I take a point 2. Now let's suppose the distance is measured from the surface of the earth. This is also x and this is also x. We have to calculate x such that the value of weight at point 1 and weight at point 2 is same. Now weight is mg. The weight of a body is what? Mass into acceleration due to gravity. So if value of g is same at both the points, then automatically weight will be same. So for point 1, g1 can be written as g upon 1 plus x by r raised to the power 2. This is the radius of the earth. Sorry. This is the center and this is the radius of the earth, r. Now for the point above the surface of the earth, the acceleration to gravity is given by this. This is the acceleration to gravity on the surface of the earth. For point 2, the value will be g into 1 minus x by r. This is the value above the surface of earth. This is the value below the surface of the earth, 1 and 2. Now, we have to do that. We have to equate these two equations. We have to equate equation 1 and equation 2, and we have to find the value of x. So equating 1 and 2, we get g upon 1 plus x by r raised to the power 2 equal to g into 1 minus x by r. Cancelling g both sides, we will be left with 1 plus x by r whole square 1 minus x by r equal to 1. Now let us assume that let x by r equal to some variable t, so that equation comes in single variable. So we can write 1 plus t whole square 1 minus t equal to 1. 1 plus t whole square 1 minus t equal to 1. Just expanding this, 1 plus t square plus 2t, and this is 1 minus t equal to 1. Just expanding the bracket, 1 plus t square plus 2t, and this is minus t cube minus 2t square equal to 1. So this 1 and 1 gets cancelled out. T square and minus t square minus t square. 2t minus t is plus t, and this is minus t cube equal to 0. So the final equation is t cube plus t square minus t equal to 0. Taking t common, t square plus t minus 1 equal to 0. Now from here, first solution we are getting t equal to 0, and second solution we are getting t square minus t plus t minus 1 equal to 0. So t equal to minus 1 plus under root b square plus 4 by 2, which is root 5 minus 1 by 2. So this solution can't be possible because it will lie on the surface of the earth. Because t we have assumed x by r, so if t equal to 0, so x equal to 0. So this point will lie on the surface of the earth. So that is understood point. The value of g is here the same. But what we have to find is at point 1 and point 2. So the correct option that we will be looking for is that the value of x by r, the valid solution is t equal to root 5 minus 1 by 2, which is x by r equal to root 5 minus 1 by 2. So x will be r by 2 into root 5 minus 1. So from the given option, we can see that this is the correct option, option number 4 for this particular question. That means at this distance, if we move up above the surface of the earth as well as below the surface of the earth, the weight of the body will be same. The weight of the body will remain same because the acceleration to gravity value will be same. Now coming to question number 18. A capacitor of capacitance 100 microfarad is charged to a potential of 12 volt and connected to a 6.4 millihenry inductor to produce oscillations. The maximum current in the circuit would be. This question is based on LC oscillation. A charged capacitor is connected to an inductor. This question is for LC oscillation, capacitor C, inductance L. Now we know that when we connect a charge capacitor with an inductor, then electrostatic energy, there is an oscillation between electrostatic energy and magnetic energy. The electrostatic energy is stored in capacitor. Electrostatic energy is stored in capacitor is given by half CV square, and the magnetic energy is stored in inductor. Magnetic energy stored in inductor is given by half Li square. The current in the through the inductor. So when the capacitor will get discharged, the total energy will be stored in the form of magnetic energy in the inductor. When the inductor will start discharging, the total current will be stored in the capacitor in the form of electrostatic energy. So there will be oscillation between these two energy. So applying energy conservation, 1 will be equal to 2. So half CV square will be equal to half Li square. So from here, half cancels out. So I square will be equal to CV square by L. I square will be equal to CV square by L. So I will be equal to V under root C by L. This is the required expression for the current that they are asking in the question. V into square root of C by L. So current will be V into square root of C by L. So what is the value of V that is given? 12. And the capacitance is given as 100 microfarad, means 10 raised to the power minus 6. And this is 6.4 millihenry. 6.4 into 10 raised to the power minus 3. Just simplifying, 100 into minus 3 and 10 minus 2. Minus 3 and one more 10 minus 2, very good. And this will be 64. So this will be cancelled out in this 12 by 8. 4 3s are 12, 4 1.5. So the current, maximum current will be 1.5 ampere. So the correct option is 3 by 2 ampere or 1.5 ampere for this particular case. Now question number 19. This question is based on the nuclear physics. The explosive in a hydrogen bomb is a mixture of this isotopes of hydrogen are given: protium, tritium, deuterium, tritium, and lithium in some condensed form. The chain reaction is given. This let's suppose this is equation 1 and this is equation 2. The intermediate reactions are given. These two reactions take place simultaneously. These are intermediate reactions, and combining these two reactions, there will be a global reaction. So during the explosion, the energy released is approximately. What they are asking is energy release, Q value of the reaction. So just if we see these two equations, I'm not rewriting the reaction. So if when these two reactions take place simultaneously, what will happen? This neutron and this neutron will cancel out, and this tritium and this tritium will get cancelled out. So what we will be left with, the global reaction will be 3Li6 plus 1 hydrogen 2 will give 2 times helium 4 2 plus that's it. Now this is the global reaction that is taking place inside the hydrogen bomb, and we have to calculate the Q value of the reaction. So the Q energy release will be simply lithium, mass of lithium in the question is given as this much, 6.01690 mu plus protium mass, deuterium mass 2.01471 minus 2 into mass of helium is provided as 4.0038, and we have to multiply it by C square. Mass defect is equals to energy equal to delta m C square. So this is the mass defect and C square. So since the unit is in AMU and C square, so 1 AMU into C square, we know that it is equals to 931.5 MeV, mega electron volt. It has been given in the question. So this we will substitute over there. Multiplied whole factor, we will multiply this whole factor with 931.5 MeV, and finally what we will get, the Q will be 22.22 MeV after solving, after multiplying by 931.5 MeV. So the correct option is option number 4 for this particular question. Option number 4 is the correct option. Now next question number 20, the last question for this section A. Two vessels A and B are of same size and are at same temperature. A contains 1 gram of hydrogen and B contains 1 gram of oxygen. PA and PB are the pressure of these gases in A and B respectively, then PA and PB is. Now two vessels are given. This is vessel A and this is vessel B. This is vessel A, this is vessel B. Here we have 1 gram of hydrogen and here we have 1 gram of oxygen. The volume of both the vessels are same and temperature of both the vessels are also same. So treating hydrogen and oxygen as ideal gas, we know that basic ideal gas equation is nRUT. where N is the number of moles of the gas, RU is the molar gas constant, universal gas constant, 8.314 joule per mole Kelvin, and T is the absolute temperature. So if this volume and temperature both are same, so P is directly proportional to N. Pressure is directly proportional to the number of moles because RU is already constant. So what we can write is here, PA upon PB will be equal to Na upon Nb. Now number of moles is the given mass upon molecular mass. So mass in A we have hydrogen, mass of hydrogen upon molecular mass of hydrogen, and here will be molecular mass of oxygen upon mass of oxygen. In both the container, mass is also same, so they will cancel out. So ultimately we will be left with molar mass of oxygen and molar mass of hydrogen, which is nothing but 32 by 2, and it will be 16. So the answer will be option number 1. Very simple question based on ideal gas equation. So the correct option is option number 1 for this particular question. Now coming to question number 21. Now the section A has been completed. From here onwards, we will be dealing with section B, which is nothing but numerical answer type question. So the first question is, when a hydrogen atom going from n equal to 2 to n equal to 1 emits a photon, its recoil speed is x by 5, where x is. So let's suppose this is hydrogen atom, nucleus of hydrogen atom, and these are the two orbits. This is n equal to 1 and this is n equal to 2. In the first orbit, the energy is 13.6 electron volt, and here minus 3.4 electron volt. Total energy if we are talking about. So when an electron transits from second orbit to first orbit, when an electron transits from second orbit to first, the transition is from second to first, then quite naturally there will be emission of energy, emission of photon. And the photon energy will be delta E equal to hc upon lambda. So this is the energy of photon that will be emitted, hc upon lambda. So rewriting this expression, we can see h by lambda equal to delta E by c equal to h by lambda, and this is nothing but momentum of photon. This is de Broglie wavelength, and this is the momentum of photon. So we will be using this particular expression because concept of momentum conservation will be applied. Now initially the hydrogen atom is at rest. If we draw a schematic, initially the hydrogen atom was at rest. This is hydrogen atom, this is H atom, and after emitting a photon, let's suppose the hydrogen atom recoils back with speed v, and the photon moves here. This is photon. So since both the velocities are in opposite direction, so naturally the momentum will be conserved. So this is rest case, this is the initial case, and that is the final case. So initial momentum will be equal to final momentum. So this is mass of hydrogen mh2, and this is velocity of hydrogen. So mh2 vh2 will be equal to momentum of photon, and momentum of photon that we have calculated is delta E by c. So velocity of hydrogen will be delta E by mc. Velocity of hydrogen will be delta E by mc. Velocity of hydrogen will be delta E by mc, mass of hydrogen times speed of light. Now the difference in the energy, delta E is 10.2 electron volt, 13.6 and 3.4 minus 3.4 will be 10.2. So this is 10.2 electron volt, mass of hydrogen is given in the question, and c is speed of light. So substituting all these values, just let's calculate. Velocity of hydrogen will be equal to 10.2 into converting electron volt into joule. Mass of hydrogen is 1.6 into 10 raised to the power minus 27, and speed of light is 3 into 10 raised to the power 8. So 1.6 gets cancelled out. Here will be 19, minus 19, and this will be again cancelled out. 27 and 8, 19, and this 19 will get cancelled out. And here will be left with 3 3s are 9.4. 3.4, and converting this 34 by 10, which will be equal to 17 by 5. Now the expression is given as this much. x by 5 meter per second. If we compare this expression with our final answer, we are getting 5 in the denominator. Here also there is 5 in the denominator. So quite obviously, the answer will be 17. The blank space will be filled by the digit 17. Now, next question, question number 22. Coming to question number 22, a ball rolls off the top of a stairway with a horizontal velocity u. The steps are 0.1 meter high and 0.1 meter wide. The minimum velocity u with which the ball just hits the step 5 of the stairway will be root x meter per second, where x is. Now, in this question, we have to draw a diagram. Suppose there is a ball which is moving with velocity u, and this is the dimension of the stair that they have mentioned in the question. 0.1 meter its height, and it is wide 0.1 meter. Now, this is the first step, this is the second, this is the third, this is the fourth, and ultimately this is the fifth step. And this is the fifth step. Now, in this question, they are telling that we have to find the minimum velocity with which the ball should be projected or it is being rolled so that it just hits the fifth step. This is step 1, step 2, step 3, step 4, and this is final step 5. Now, if you see that if we are able to, I am drawing this trajectory. If our ball is just able to clear the step 4 at this point, where the step 4 is ending, if our ball is able to clear this step 4 where our step 4 is ending, then naturally it will hit on step 5 somewhere. So the limiting condition will be imposed on step 4, not on step 5. ठीक है ना? एक गलत solution ये भी हो सकता है कि you can project the ball on this point. White, just see at the white trajectory. So this particular solution will be wrong because more velocity you will be getting. We have to find minimum velocity, least velocity which can land the ball successfully on step number 5. So this is possible if we are able to make our ball clear this point. Now, you can just applying the kinematic equation. So 1, 2, 3, and 4. So this horizontal range is 0.1 into 4, 0.4 meter, and this vertical height that the ball has descended, this vertical height is 1, 2, 3, 4, 0.4 meter vertical height, h. So since during the projection the vertical velocity is 0, so the time the ball will take to land will be under root t equal to under root 2h by g. 2 into time, height is 0.4 and it is 10. So 104 to the 8 by 100. So root 8 by 10 to root 2 by 5 second. This is the time taken by the ball. Now, since the ball has only horizontal components which will not change during its motion, as it is the case of projectile motion, so the range r will be speed into time. So this is 0.4 and u into time is root 2 by 5. So if we do a little bit simplification, so what we will be getting is u barabar 0.4 into 5 by root 2. This will be equal to 2 by root 2 and root 2. So in the question they are saying that the speed is expressed as root x meter per second. So clearly the value of x will be 2. So here the answer will be 2. Here the answer will be 2. So the correct answer is 2, and the velocity will be root 2 meter per second. If the ball is rolling from here with a speed of root 2 meter per second, then it will just clear the step 4 and will land successfully on step 5. Now coming to question number 23. A square loop of side 10 centimeter and resistance 0.7 ohm is placed vertically in east-west plane. A uniform magnetic field of 0.2 Tesla is set up across the plane in northeast direction. The magnetic field is decreased to 0 in 1 second at a steady rate. The magnitude of induced EMF is root x into 10 raised to the power minus 3 volt. The value of x is. Now in this question is based on Faraday law. We have to draw a little bit of diagram. Now let's suppose this is our north, this is our south, this is our east, and this is our west. And let's suppose this is our square plane. As far as figure is concerned, this is square loop is coming outward. Square loop is coming outward. Okay, na? In the vertical east-west plane, this half portion is behind the board and half portion is in front of the board. Now the magnetic field that they have applied is in the direction of northeast, means 45 degree from here also and 45 degree from here also, and the value of B is given in the question as 0.2 Tesla. And the resistance of 0.0 is placed vertically in east-west plane. Uniform magnetic field of 0.2 set up across the plane. The dimension of the square loop is 10 centimeter. The magnetic field is decreased to 0 and stated that the magnitude of EMF is. Now, if we calculate the flux, since magnetic field is constant, it will be nothing but BA cos theta. This will be the area vector. This will be the area vector of the loop. This will be the area vector of the square loop, and area vector and magnetic field are making an angle of 45 degree with each other. So BA will be 0.2. and the dimension is 10 centimeter, means 1 by 10 meter, so 1 by 100, and cos theta will be 1 by root 2. So root 2 by 1000 Weber will be the flux. This is the flux of the magnetic field. Now in the question we know that now Faraday laws, as per Faraday law, the induced EMF will be change in flux upon time taken. Now since the magnetic field is decreased to 0 in 1 second. Initially the magnetic field was 0.2 Tesla, now it is 0. So the final flux will be 0. The change will be equal to root 2 by 1000 itself, and time is 1. So root 2 into 10 raised to the power minus 3. So this is the expression of induced EMF. Now this, if we compare this expression with our answer, then we can see that x will be nothing but 2. The value of x will be nothing but 2, because we are getting x equal to 2 over here. So the correct answer is 2. Coming to question number 24. A cylinder is rolling down an inclined plane of inclination 60 degree. Its acceleration during rolling down will be x by root 3, where x is. It's a very basic question on pure rolling down an inclined plane. This is the inclined plane whose inclination is theta is equal to 60 degree. And a cylindrical object is rolling down this inclined plane, So we have to calculate the acceleration of the center of mass. This is center of mass, this is acceleration cm. So it's a very basic question. There is a ready-made formula for the acceleration of center of mass when a spherical object rolls down an inclined plane. That is nothing but g sine theta upon 1 plus lambda. What is lambda? Lambda is the coefficient that is used in the expression for moment of inertia depending upon the geometry of the body. So since this is cylinder, so its moment of inertia about its center of mass axis will be half mr square. So this is lambda, the coefficient in the expression of moment of inertia. So just substituting all these values, we can get the value of g is 10. The value of g is 10 sine 60 degree upon 1 plus half. So this will be equal to 20 by 3, and sine 60 is root 3 by 2, 210, 10 by root 3. So if we compare our expression with this expression, so we can see that the value of x will be 10. So here the value of x will be 10. Now coming to question number 25. The magnetic potential due to a magnetic dipole at a point on its axis situated at a distance of 20 centimeter from its center is 1.5 into 10 raised to the power of minus 5 Tesla meter. The magnetic moment of the dipole is. This question is from magnetic dipole moment. We know that the magnetic potential, the value of magnetic potential is given by mu naught upon 4 pi magnitude of magnetic moment upon r square. And this question is given by 1.5 into 10 raised to the power minus 5. Now what we have to do, we have to just calculate the value of m. So the value of magnetic moment m vector will be 1.5 into 10 raised to the power minus 5 into r square into 4 pi upon mu naught. Substituting all the values, 10 raised to the power minus 5. Now the distance is 20 centimeter, means 1 by 5 meter, 1 by 25, and here is 4 pi, and here is mu naught permittivity of free space, 4 pi into 10 to the power minus 7. This 4 pi will get cancelled out. So the final expression will be 1.5 10 to the power minus 5 10 to the 1.5 into 100 by 25. So this will be 150 by 25. 150 by 25, 5, 3, 6. So the correct answer will be 6 ampere meter square. So the magnetic moment, the value of magnetic dipole moment will be 6 ampere meter square. So moving on to next question, question number 26. This question is based basically on a double slit experiment. The diagram is a little bit modified. It's not the conventional diagram that is given in the book. So if we look into this figure, the source is provided here. So the first wave coming from here will pass through this slit and will come at point P, and the second wave will travel from this source and will meet at point P. So this is the point of interference, and here we are getting dark fringe as per question. As per question, we are getting dark fringe. So if I number this as wave 1, if I number this as wave 1 and this I number this as wave 2, so path for wave 1, path length for first wave is 2 times x. If I call this distance x, this x and this x, so this x plus x will be 2x, and path length for second wave is 2d, d plus d, 2d. So path difference is equal to 2x minus 2d. Path difference is 2x minus 2d. Now the point is that if we can calculate x in terms of d and small d, then it will be capital D square plus small d square minus 2d. Using just Pythagoras theorem, this is capital D, this is small d, so but natural that hypotenuse will be under root capital D square plus small d square. So this is the path difference. Now we know that for dark fringe, we know that this path difference should be equal to odd multiple of lambda by 2. Path difference should be equal to odd multiple of lambda by 2. Now, just we can see from the above expression that path difference we are getting this much. So this 2 into under root d square plus d square minus 2d is equal to 2n minus 1 into lambda by 2. Now in the question they are saying that we have to find the minimum distance. We have to find the minimum distance. मतलब d की कम से कम वैल्यू निकालनी है, तो d की कम से कम वैल्यू तभी होगी जब n की कम से कम वैल्यू रखें. अब n की जो मिनिमम वैल्यू यहाँ पे पुट की जा सकती है, that will be equal to 1. So corresponding to n equal to 1, we will be getting the minimum value of d. So अब यहाँ पर अगर n को 1 रखूंगा तो ये simply lambda by 2 बन के आ जाएगा. ठीक है, 2 1 2 minus 1 1 2 lambda by 2. अब इसको just solve कर लेना है. So तो इसको अगर हम लोग सिंप्लीफाई करें तो डी स्क्वायर प्लस डी स्क्वायर माइनस कैपिटल डी विल बी लैम्डा बाई 4, 2 उधर जाके 4 हो जाएगा, और इस कैपिटल डी को उधर ले जाते हैं तो ये हो जाएगा डी प्लस लैम्डा बाई 4. स्क्वेयरिंग बोथ साइड्स वी गेट डी स्क्वायर प्लस डी स्क्वायर बराबर डी स्क्वायर प्लस लैम्डा स्क्वायर बाई 16 प्लस डी लैम्डा बाई 2. अब ये डी स्क्वायर से डी स्क्वायर कैंसिल हो जाएगा. नाउ द सिंपल एक्सप्रेशन कम्स आउट टू बी डी स्क्वायर इक्वल टू लैम्डा स्क्वायर बाई 16 प्लस डी लैम्डा बाई 2. ये एक्सप्रेशन हमारा बन के आता है फाइनल. अब सारी वैल्यूज हमको क्वेश्चन में दे रखी हैं. व्हाट वी हैव टू डू, वी हैव टू जस्ट सब्स्टिट्यूट दीज वैल्यूज एंड गेट द आंसर. तो स्मॉल डी स्क्वायर की जो वैल्यू है दैट इज लैम्डा स्क्वायर बाई 16. लैम्डा की वैल्यू दे रखी है 400 नैनोमीटर. तो 410 रेज टू द पावर -9 का होल स्क्वायर अपॉन 16 प्लस कैपिटल डी मतलब स्क्रीन डिस्टेंस जो दे रखा है, ये कैपिटल डी की वैल्यू दे रखी है 0.2, फिर लैम्डा 400 इंटू 10 का पावर -9 और यहाँ पर ये 2. अब इसको अगर सॉल्व कर लेंगे और फिर हम लोग को रूट ले लेना है इसका, इस पूरे एक्सप्रेशन का रूट ले लेना है, और यहाँ से मैं 2 को हटा दे रहा हूँ. तो इसको जब सॉल्व करेंगे और तो जो आंसर हमारा आएगा इस पूरे एक्सप्रेशन को सॉल्व करके, तो वो अप्रॉक्सीमेटली आपको 0.2 mm आएगा आफ्टर मल्टीप्लाइंग बाई 1000, क्योंकि ये सारा कुछ मीटर में आएगा. तो मीटर को फिर हम लोग को mm में कन्वर्ट करना है, तो लास्ट में एक्सप्रेशन को हम लोग को 1000 से मल्टीप्लाई करना पड़ेगा. सो आंसर विल बी 0.2 mm. तो करेक्ट आंसर इज 0.2 mm. Next, moving to the next question, question number 27. A 16 ohm wire is bent to form a square loop. A 9 volt battery with internal resistance 1 ohm is connected across one of its sides. If a 4 microfarad capacitor is connected across one of its diagonal, the energy stored by the capacitor will be x by 2 microjoule, where x is equal to. A wire is being bent in the form of a square. So this is the circuit that they are talking about. A 16 ohm wire is bent to form a square loop. A 9 volt battery with internal resistance 1 ohm. This is a 9 volt battery and its internal resistance is 1 ohm. Is connected across one of its sides. If a 4 microfarad capacitor, this capacitor is a 4 microfarad capacitor, is connected across one of its diagonal, the energy stored by the capacitor will be. Now since the total resistance is 16 ohm and we are bending it into form of a square, so all the sides will be of same length, so the resistance will be 4 ohm each, because the length is 1/4 of the length is getting 1/4. So this is also 4 ohm, this is also 4 ohm, this is also 4 ohm. Now we have to solve this particular circuit in a steady state. We have to solve this circuit under a steady state condition. So under steady state condition, the entire capacitor will be get fully charged and it will become an open circuit. The capacitor will become open circuit. So we can redraw this circuit as follows. And here it is an open circuit. Now the battery is of 9 volt and this is the internal resistance. Now we can see easily that the above 3 resistance are connected in series, which is in parallel with this 4 ohm resistance, and then it is in series. So what we can do, we can calculate the total current that is sent by the battery. So this 4 ohm becomes 12 ohm. Now 12 ohm and 4 ohm, redraw the circuit. This is 12 ohm and this is 4 ohm and this is the battery. 1 ohm and this is 9 volt battery. So the total is 4 and ohm, the 12 ohm and 4 ohm are connected in parallel. So their equivalent will be 12 into 4 by 16, 4 equal to 3 ohm. and this combination of this 3 ohm and this 1 ohm is in series, so the total current will be 3 plus 9 by 3 plus 1 इक्वल टू 9 by 4 एम्पियर। इन दोनों का जो इक्विवेलेंट होगा 3 ओम वो इस 1 ओम के साथ सीरीज में होगा, तो टोटल रेजिस्टेंस हो गया 4 ओम सर्किट का, और बैटरी लगी हुई 9 वोल्ट की, तो V बाई आर इक्विवेलेंट से 9 by 4 एम्पियर टोटल करंट, मतलब बैटरी ने 9 by 4 एम्पियर का करंट सप्लाई किया है इस पूरे सर्किट में। अब अगर देखा जाए इफ यू सी कि 9 वोल्ट की बैटरी है, 9 by 4 एम्पियर का करंट यहाँ से भी फ्लो कर जाएगा, तो यहाँ जो इस रेजिस्टेंस के अक्रॉस पोटेंशियल ड्रॉप हुआ है, तो पोटेंशियल ड्रॉप इस रेजिस्टेंस के अक्रॉस जो होगा वो हो जाएगा 9 by 4 वोल्ट का। 9 by 4 वोल्ट का पोटेंशियल ड्रॉप इस रेजिस्टेंस के अक्रॉस हो जाएगा, और बैटरी लगी है 9 वोल्ट की, तो रिमेनिंग पोटेंशियल ड्रॉप इस रेजिस्टेंस में आ जाएगा 9 minus 9 by 4, 9 minus 9 by 4 मतलब 27 by 4। तो यहाँ जो पोटेंशियल ड्रॉप होगा इस पर्टिकुलर रेजिस्टेंस में, दैट इज 27 by 4 वोल्ट। ये 27 by 4 वोल्ट का पोटेंशियल ड्रॉप यहाँ पर होगा। अब ये 27 by 4 वोल्ट का पोटेंशियल ड्रॉप इसके अक्रॉस भी है, 12 ओम के अक्रॉस भी है, तो 12 ओम के अक्रॉस अगर पोटेंशियल ड्रॉप 27 by 4 है, सो द करंट अक्रॉस 12 by 4 एम्पियर विल बी V by R, so 27 by 4 into 12, 3934, 9 by 16 एम्पियर। 9 by 16 एम्पियर करंट फ्लो कर रहा है इस पर्टिकुलर ब्रांच में। अब ये 12 ओम जो करंट सर्किट रेजिस्टेंस है, दिस वाज द इक्विवेलेंट ऑफ दीज 3 कनेक्टेड इन सीरीज, सो इन तीनों के साथ 9 by 16 एम्पियर का करंट फ्लो कर जाएगा, क्योंकि जो इक्विवेलेंट से फ्लो करता है वही इंडिविजुअल से, तो 9 by 16 एम्पियर यहाँ भी, 9 by 16 एम्पियर यहाँ भी, और 9 by 16 एम्पियर यहाँ भी, इन तीनों से करंट फ्लो कर जाएगा। नाउ कैपेसिटर कनेक्टेड है, लेट सपोज दिस इज पॉइंट ए एंड दिस इज पॉइंट बी। अब अगर ए और बी के बीच का पोटेंशियल हमें पता चल जाए, ए और बी के बीच का पोटेंशियल डिफरेंस पता चल जाए, देन वी विल बी इजीली एबल टू सॉल्व द सर्किट एंड कैलकुलेट द एनर्जी। सो अगर हम लोग इस पॉइंट को देखें तो ए पॉइंट का पोटेंशियल है 9 वोल्ट बिकॉज इट इज डायरेक्टली कनेक्टेड विद द बैटरी। ए पॉइंट का पोटेंशियल है 9 वोल्ट, इट इज डायरेक्टली कनेक्टेड विद द बैटरी। अब अगर हम लोग देखें 9 वोल्ट का पोटेंशियल यहाँ पर है और करंट फ्लो कर रहा है 9 by 16 एम्पियर, तो पोटेंशियल ड्रॉप इसमें आई आर 9 by 4 एम्पियर का होगा। इस पर्टिकुलर ब्रांच में पोटेंशियल ड्रॉप कितने का हो जाएगा, करंट इनटू रेजिस्टेंस V बराबर आई आर, तो 4 9 by 4 और 9 यहाँ है, तो यहाँ कितना होगा 9 minus 9 by 4, 27 by 4, तो यहाँ का पोटेंशियल हो गया 27 by 4 वोल्ट। फिर अगर देखें अब यहाँ 9 by 16 है, 4 है, तो फिर 27 by 4 से पोटेंशियल ड्रॉप हुआ 9 by 4 का, तो 27 by 4 minus 9 by 4, 18 by 4, 4.5 वोल्ट। सो बी पॉइंट का जो पोटेंशियल आया 4.5 वोल्ट। सो ए पॉइंट का पोटेंशियल है 9 वोल्ट, बी पॉइंट का पोटेंशियल है 4.5 वोल्ट। द पोटेंशियल डिफरेंस अक्रॉस द कैपेसिटर इज ऑफ 4.5 वोल्ट, 9 minus 4.5। सो एनर्जी स्टोर्ड इन द कैपेसिटर फाइनली विल बी E इक्वल टू हाफ CV स्क्वायर, हाफ इंटू कैपेसिटेंस कितनी हो गई दे रखी है क्वेश्चन में, 4 माइक्रोफराड मीन्स 4, और पोटेंशियल है 4.5 वोल्ट, 4.5 स्क्वायर, तो ये 2 हो गया, 4.5 by 2 मतलब 9 by 2, 81 by 4, 2। सो इफ यू सी द जो हमारा एक्सप्रेशन आया है वो 81 by 2 माइक्रोजूल। नाउ इफ वी कंपेयर आवर फाइनल आंसर विद द व्हाट गिवन इन द क्वेश्चन, वी कैन सी दैट x इज इक्वल टू 81, x की वैल्यू है 81, सो द करेक्ट आंसर इज 81। Coming to question number 28, when the displacement of a simple harmonic oscillator is 1/3 of its amplitude, the ratio of total energy to the kinetic energy is x by 8. What is the value of x? Now, in a simple harmonic oscillator, kinetic energy, linear simple harmonic oscillator, half m omega square into a square minus x square. This is the kinetic energy, expression for kinetic energy. M is the mass, omega is the angular frequency, a is the amplitude, and x is the displacement. Now the total energy of a simple harmonic oscillator is always constant, half m omega square a square. Now the ratio of these two, if we divide these two equations, kinetic energy upon total energy, what we will be getting, that this term will be cancelling out, and it will be a square minus x square upon a square, which is nothing but 1 minus x by a whole square. Now this ratio, the total energy to kinetic energy, is x by 8. Okay. So kinetic energy upon total energy, 1 minus x, 1/3 of the amplitude. So this 1 minus x is 1 by 3, 1 by 9, 8 by 9. So the total energy upon kinetic energy will be 9 by 8. So if we compare our final answer with this particular expression, so we will be clearly seeing that the value of x is what? 9. So the correct answer is 9. Coming to question number 29, an electron moving under the influence of the electric field of a uniformly charged infinite plane sheet S having surface charge density plus sigma, the electron at t equal to 0 is at a distance of 1 meter from S and has a speed of 1 meter per second. The maximum value of sigma if the electron strikes S at t equal to 1 is alpha m epsilon naught by E coulomb per meter square, the value of alpha is. So let's represent the question on a diagram. This is a plane sheet, and from this sheet, let's draw an x-axis. Here it is origin, and initially this is 1 meter comma 0, and the electron here is moving with 1 meter per second velocity in the forward direction. Now this sheet has a surface charge density plus sigma. This is given in the question, and let's suppose mass of electron is m. Now we know that the electric field due to the sheet, is sigma upon 2 epsilon naught. This is the value of electric field due to a sheet, and since it is a positively charged sheet, the charge density is plus sigma, the value of electric field will be away from the sheet. So here the value of E vector will be in this direction. Now since the charge on electron is negative, so force on the electron will be acting in the backward direction. So this is the force on the electron, which is nothing but Q into E. Minus EE. It will act in the backward direction. The force on the electron will be acting in the backward direction. Now this electron is initially moving in the forward direction, and force is acting in the backward direction. So acceleration is towards negative x-axis, and the electron is moving towards positive x-axis. So the electron will start deaccelerating, and after going certain distance in the forward direction, it will come to at rest, and from that point it will return back and it will hit the sheet. This is the physical situation of the problem. You cannot assume the initial velocity initially toward the sheet. The direction of this 1 meter per second velocity cannot be toward the sheet at t equal to 0. Why? Because the distance is 1 meter and its velocity is also 1 meter per second. So without any acceleration, it will hit the plate in 1 second. But since the plate is charged, the sheet is charged, so quite naturally the electron will be having some acceleration. So the time taken to hit the plate can never be 1 second, it will always be less than 1 second. So from this point we can say that the velocity 1 meter per second should be in the forward direction, not in the backward direction. This is the situation at t equal to 1, this t equal to 0, and the electron is hitting at t equal to 1 second at this point. Now if we calculate the acceleration of electron, the acceleration of electron will be F upon m. F is E by m, and value of electric field will be E sigma upon 2m epsilon naught. This is the value of acceleration, and the acceleration is in the backward direction. This is the acceleration towards negative x-axis. Now applying our kinematic equation along x-axis, xt equal to x0 plus vx0 t plus half a t square. This is the final instant, this is the initial instant. The final instant, the coordinate is 0. The initial instant, the coordinate is 1. The initial velocity is toward x-axis, so it is plus 1. Time is 1 second. Now acceleration is toward negative x-axis, that's why we will be using negative sign, and the expression for acceleration is The expression for acceleration was F by m, E by m, and that will be E sigma by 2m epsilon naught. Sigma E by 2m epsilon naught. Sigma E by 2m epsilon naught, and time is 1 whole square. So now if we solve this particular situation, 0 equal to 1 plus 1, 2 minus sigma E upon 4m epsilon naught, and from here we can see that sigma E upon m epsilon naught will come out to be 8. Sorry. If we solve a little bit, so what we will be getting is that sigma E upon 4m epsilon naught will be equal to 2. So m epsilon naught upon sigma E into 8 equal to strikes the value of sigma 1. So sigma will be 8 times of m epsilon naught by E. So if we compare our this particular expression with alpha, m epsilon naught by E, we are getting that the coefficient alpha, the value of coefficient alpha is equal to 8. So the value of coefficient alpha is 8 in this particular answer. Now coming to question number 30, the last question of section B. In a test experiment on model of aeroplane in wind tunnel, the flow speed on upper and lower surface of wings are 70 meter per second and 65 meter per second respectively. If the wing area is 2 meter square, the lift of the wing is. This question is based on Bernoulli's principle and aerodynamic lift, and the concept involved is aerodynamic lift. So if I draw a section of an airfoil, so this, let's suppose this is point 1 and this is point 2. On the airfoil, this is a section of airfoil. This is the section of airfoil, wings of plane. Now, at point 1, the velocity at point the upper surface and lower surface. Upper surface velocity is given as v1 equal to 70 meter per second, and at lower surface velocity is given as v2 equal to 65 meter per second. So at the upper surface, the pressure will be smaller, let's suppose P1, and at the lower surface, the pressure will be larger as per Bernoulli's principle. Because these 2 points are very close to each other, the wings of aircraft are very thin. So there will be no effect of elevation or datum. The elevation effect will be neglected. So we can assume, we can say that the point where where velocity is high, the pressure will be low, and the point where velocity is low, pressure will be high, because the pressure energy and the kinetic energy are conserved. So applying Bernoulli theorem at Bernoulli equation at 1 and 2, we can get that P1 plus rho V1 square by 2 is equal to P2 plus rho V2 square by 2. So from here we can see that P2 minus P1 will be equal to rho V1 square minus V2 square by 2. This is the required expression for the pressure difference that we are getting. Now, what we have to calculate? We have to calculate the lift. Lift is nothing but the force. Since here the pressure is high, here the pressure is low, so here force will be low, here force will be high. So net force will be in the upward direction. So the lift will be simply P2 minus P1 into area of wing. Area of wing. So just writing the expression rho by 2. V1 square minus V2 square into area. So density of air is given 1.2 by 2, 70 square minus 65 square into area. Area of wing is given as 2 meter square. So this 2 will cancel out. 1.2, 70 plus 65, and this is 70 minus 65. 70 minus 65 will be 5, it will be 1.256, and this will be 135. And 135 into 6 will be 30 78, 79, 80, 81. 810 Newton. So the lift generated will be 810 Newton. So this is the final answer. So I have, as you can see, the direction of this lift. The direction of this lift will be one more thing. It will be in the upward direction. This lift will be in the upward direction. So through this session, I have come to an end with the solution of this paper. That was 29th January, morning shift, JEE Main Physics paper. So I hope that you all have watched the video and got through your working on the day of exam. In the next video, I will be coming up with the morning shift solution of paper on 30th January. Till then, thank you.